So we're here at the Fraunhofer Heinrich Hertz Institute, and who are you?
My name is Ralf Schäfer. I'm head of the image processing department here at Fraunhofer Heinrich Hertz Institute, and we are working on everything which has to do with images and video.
So here you have a presentation showing what HHI is all about, right? Inside Fraunhofer?
I have a presentation which at the beginning explains what Fraunhofer is about, so the whole organization, and then I will shortly touch what we are doing at Fraunhofer HHI, and afterwards I will talk what we are doing in the image processing department.
So let's see, so can you just start? Heinrich Hertz, what did he do?
Oh, Heinrich Hertz is a very famous researcher, and all the unity for the oscillations is measured in hertz. So everybody knows about kilohertz and megahertz, and that's the person which from whom the name comes from.
And the section that you're talking about is just one of the HHI Institute sections, or is it general HHI? What are you talking about now?
I will shortly talk about the HHI in general, but then focus on what my department is doing.
All right. So driving the gigabit society. So that's like a tagline, like the gigabit internet. Are you talking about, or?
Sure. We have more and more data, and so as you know, the whole data traffic in the internet is dominated by video. So the amount of video is now at about 50%. It will grow up to 70 or even 80% in the future. And we are working on video, so we think we are working on something very important. And especially what we do, and I will come back to that later, we are working on compression, because video sources nowadays generate such huge amount of data that it's impossible to transmit that without compression, and that's one of our main topics.
So you did, Fraunhofer did the MP3, the audio, and also like all the video stuff. You're involved in all of that.
So audio is done by our colleagues in another Fraunhofer Institute, Fraunhofer IS, which stands for Institute for Integrated Circuits, which is located in Erlangen, about 600 kilometers, or no, 400 kilometers from here to the south. And as I will explain, Fraunhofer consists of about 60 different institutes working in all different fields of applied research. And so Fraunhofer HHI is one of the 60s, and Fraunhofer IES, which does the audio stuff, is also one of these.
All right, so let's check out what are you going to show here?
Okay. So this is a map of Germany, and it tells you that we have about 80 units. 60 of them are complete institutes, with about 100 to 300 people in each institute. So the whole Fraunhofer society has more than 20,000 employees. So most of the units are in Germany, but we have also units in the US, for example, or other countries. And we have offices all over the world, especially also in Asia, China, Japan, Korea, but also in the US and South America, for example.
So we're here right now.
We are here in the capital of Germany, which is Berlin. And in Berlin we have 3 Fraunhofer institutes, and all these points indicate where Fraunhofer institutes are located.
The SI one, the audio one, where is that one?
They are, I hope, they should be here. So
yeah. All right. So image processing division, or what do you institute? Oh, what do you call it?
That's the Heinrich Hertz Institute is, and I will explain that now later. So yes, maybe a few words before. So the Fraunhofer Society is organized in so-called groups. And groups and institutes working on similar areas belong to a certain group. And one of these groups are microelectronics, where Fraunhofer HHI belongs to. There is another group of information and communication technology, where HHI is also a guest member. And we are also guest member in the Defense and Security Research Group. Another thing in Fraunhofer is so-called alliances. And in these alliances, there are institutes also from different groups, but working on similar topics. For example, a lot of institutes are working on embedded systems, and therefore there's an alliance on embedded system, because you can have embedded system in very different areas, in medical and other areas, and therefore we have these alliances.
What's the ambient assisted living?
Oh, that's especially for helping people, especially elder people, to live, being connected to other people, being helped by medical services in their home, mainly. And the third instrument we have in Fraunhofer is these so-called clusters. Clusters is a number. For example, here in Berlin we have 3 different institutes.
Are there 2 other in Berlin or outside?
There are even more in Berlin.
Yeah.
So there's also one outside. So Berlin and Brandenburg. So that's the surrounding area. It's called Brandenburg, and they are very close. So they are in Potsdam, so they in these clusters, some local Fraunhofer institutes work together with some local industries on special topics. Especially in this first topic, we are working together with some companies in the next generation idea, for example, passports with active displays and this kind of things. And here we work together in the life cycle engineering of turbo machines. We are working together with some manufacturers of turbo machines, where especially we work on how to visualize the research results of this.
What is a life cycle engineer of turbo machines? What does that mean? What is a turbo machine?
Turbo machines are, for example, for airplanes or for power plants. So very, very big machines which either generate electricity or drive big things like airplanes.
Sounds fun.
Yeah.
Right.
Okay, then yes. So Fraunhofer HHI has been already founded in 1927, and then in '86 we started work on optical.
You mean 68?
68, sorry.
Yeah.
We started work on optical fiber transmission.
Not fiber internet?
That was, the internet did not exist yet in the 80s, but we started off one of the first and working on optical transmission. We were the first doing a 1 gigabit transmission over optical fibers. We worked on some terrestrial broadcast systems. In 2000 we started working on 3D technology. Then since quite some time we are working on photonic networks, not just optical transmission, but whole photonic networks and the components for these networks.
What's a photonic network?
Photonic network is a network which does no longer transmit electrical signals, but just optical signals. So you have optical switching, and you have lasers, you have photodiodes. And
is it being used as just research?
No, that's already in use since a lot of years, but of course there's a demand always to increase the capacity. You know, the first transmission started with one gigabit per second. Now we are at terabit, which is...
That means transmission of data on fiber? Is that what it means?
On fiber, yeah.
Okay.
And yes, we are in the last year we got a new department which works on fiber optical sensor systems. which means that you also can use fibers, for example, to measure temperature or tension of some objects. And then we also founded a new section in HHI which deals with high-speed hardware, which tries to fill the gap between the optical area and the electronic area.
High-speed hardware.
Yeah, because if you want to transmit bits at very high speed, for example of terabit per second, at the end you need to come back to the electrical signal because you want to feed it into PCs or whatever, and to bridge the gap between the optical area and the electronic area. So that's what these people do.
Like on the internet, there's a big box, and then there's a long cable, and there's another big box on the other side.
Right. Yeah.
All right.
Maybe we skip that. Yeah. So these are some highlights in the history of HHI, what has been invented. So it already started in 1932.
Funkerausstellung. Is Sennheiser related with HHI?
Yes, so he worked here at HHI, so there are some famous people working here at HHI. So in 2004 we did the first 1 gigabit per second wireless transmission. So that was one thing. In 2008 we got the Emmy Award for the development for H.264. And in 2009 we got the Vodafone Innovation Prize, another award in 2010, also very famous German award, also for video compression. We participated in the expo in Shanghai. We helped to organize the world's first 3D broadcast live event, which was transmitted to 90 movie theaters in 5 countries in Europe. And then in 2011 or since a few years we work on visible light communication, which means that instead of lamps we're using LEDs, and you can modulate these LEDs, and you can use such a lamp as a transmitter and, for example, receive the signal on your laptop. So you have a very high-speed connection, wireless high-speed connection with light from the lamp to your laptop.
Is this like just research stage, or is it for real? Is like people using this?
It's still in the research area more, but that will come quite soon.
If you look at the light, does it like flicker and stuff? Is it bad for the eyes, or?
No, it's flickering so fast, so it's
just it could be like a normal light, but it transmits data. Maybe.
Yeah, because if the flickering is above 100 hertz, then you can't see it anymore. And this is flickering at megahertz, so much faster than
that
the eye
sounds cool.
can see.
So there would be some kind of camera on this side looking at the light,
right?
And that's it.
That's it.
You get data.
It's not a camera; it's a photodiode or an array of photodiodes. But then it can receive the light, nice. Demodulate it, and then you have very high capacity data. And the nice thing is you can move everywhere in the room, so you need no connection. And especially in places where maybe
as far as the light can reach, it would work, or you need to be close enough for it to work.
Yeah.
You need to be in focus, or what's it called?
No. You don't need to be in focus, but you have you need a direct sight.
So it can go very far. Up to the mountain.
No, not so far. It's more for communication within one room, or some big halls, and so where cabling is difficult, or also where wireless transmission is difficult. For example, if you have some plants where there's a lot of machines going on, their radio is very difficult, and their light communication is much easier. It's not disturbed by the machines, for example.
All right.
Also in, for example, in hospitals where you are not allowed to use radio, they could use light communication. So there are a lot of interesting applications for that.
All right. So that's coming, I guess.
That's coming in the next year. So it's coming more and more. It's still more in the research area, but first products will come out soon.
All this is being done right here.
It's not in this building, but it's done in the in the main building. Yeah, that was, you know, we have a long history in establishing world records for very high speed transmission over one fiber, and that was a world record of 10 terabit per second on a single optical fiber.
Nice. I'd like to have that connection at home.
Yes, so sure.
Yeah. So I can upload my videos a little bit faster.
Yeah.
All right.
But that's not just for a single person, but maybe that's for a whole city. Yeah.
All right. Is this it? The presentation, or you have more?
Oh, we have more. So
yeah.
Maybe you skip that. Skip that as well. Yeah. So what Fraunhofer institutes normally have is also very strong connections to the local universities. So the director, which is Professor Grallert at the moment, he has a chair at the Technical University, but there are two more people who have also chair at the Technical University. So we have also people who have also chairs at other university, for example at the Humboldt University. Then these fiber sensor systems I mentioned before is not located in Berlin, but it's located outside of Berlin in near on Goslar, and there's also a connection to the local University of Clausthal. And then we have two other local university where some stuff of HHI is working, and there's another one which is just in preparation, which will be established next year, which is in Potsdam, is a city which is just a neighbor city to Berlin. So it's very important that Fraunhofer institutes and local universities are very closely connected because it's a win-win situation for both. So we get a lot of students from these universities, which then we can hire afterwards. But the people from the universities, for example, they can use our equipment because normally we have better equipment than universities.
All right.
Yeah. So yes, what we have. So we have mainly 4 business segments in HHI. We have the image processing, interactive media, and that we call electronic imaging. Then we have the communication networks part, which on the one hand is the mobile broadband networks, and then the photonic networks, which are fiber networks. And then we have a third division, which is photonic components, which do all the lasers, photodiodes, switches, and so on, everything which is working in the optical area. And then we have these fiber optical sensor systems. And then, as I mentioned before, we have also the high-speed hardware architectures, which develops FPGA chips and boards. And what we also try to do, we try to apply these technologies also in other areas, for example, in the medical area and in the security area. We have no dedicated department working on medical technologies, but we know that a lot of technologies we develop here are also usable in the medical area. For example, 3D technologies you can use in surgery. If you use endoscopes, more and more 3D endoscopes are used, and 3D monitors and so on.
4K? What do you do with 4K?
4K is also a topic we look at. We even go beyond 4K. So we have here a system at HHI which works even with 10K or 7K. any number. So we are looking very far in the future beyond what's on the market right now.
Sounds awesome. All right.
So this summary of all these areas we are working on.
So you, by the way, you're just doing the movie with what's his name? Not Tom Hanks, but the other guy. Minority Report. That's what you do.
Yeah, that's something which is done here in the electronic interactive media media department, where they do some gesture control, for example, of such monitors, so that you don't need a touch screen anymore, but you just control the display by your gestures. That's also an important topic we work here at HHI.
Sounds awesome. We should go and check it out, all this stuff.
Okay.
Let's go.
Okay.
All right.